for the next section, we're looking at how to factor polynomials. We're going to look at a whole equation in standard form, and we're going to look at how we would be able to factor it down so that we can determine the number of roots, what the roots are, the leading coefficient, all of that stuff. So basically turn an equation, a polynomial equation in standard form into factored form. The remainder theorem, let's go ahead and divide it and let's see what we can discover. So x squared plus 3x plus 2 divided by x plus 2. Just a quick revision in explaining remainder theorem. We're going to look at what happens when we divide a polynomial by another polynomial and its relation to the value of that, or the y value of that polynomial. So first we're going to divide. So x squared plus 3x plus 2, as we learned, we're going to start with these two. So x squared divided by x is x. X times x is x squared. X times 2 is 2x. Then we'll subtract. These two cancel out. 3x minus 2x is 1x plus 2, and that leaves a 1. So 1 times x is x. 1 times 2 is 2. Cancels out. There's a remainder of 0. It's the same thing here. By the way, we know now that x plus 2 is a factor because there's a remainder of 0. So x squared plus 3x plus 2 divided by x minus 3. So we'll have x squared plus 3x plus 2 divided by x minus 3. Same idea. The first two terms are the ones we look at. X squared divided by x is just x. This becomes x squared minus 3x. We go through and we subtract it. X squared minus x squared is 0. 3x minus negative 3x is positive 6x. Bring down the plus 2. Now we do 6x divided by x to get the 6. 6 times x is 6x. 6 times negative 3 is minus 18. We're going to subtract all of this. 6x minus 6x is 0. 2 minus a negative 18 becomes 2 plus 18 is 20. So when we take x squared plus 3x plus 2, if we divide by x plus 2, we'll get 0. If we divide by x minus 3, we'll get 20. I'm looking at the remainder specifically. So for this one, the remainder would be 0. And for this one, the remainder is 20. Now let's compare that to what the y value would be at each of these points. Each of the points that are dictated by the divisor. So x plus 2 means x is negative 2, and x minus 3 means x is positive 3. So let's find out what is f of negative 2. What's the x value? Sorry, what's the y value for this equation when x is negative 2? So I'll have negative 2 squared plus 3 times, I'm just writing the same equation out. X squared plus 3x plus 2. This becomes 4 minus 6 plus 2. 4 plus 2 is 6. Minus 6 is 0. So the remainder is the same thing as the y value. Let's verify that over here. F of 3 would be 3 squared plus 3 times 3 plus 2. 9 plus 9 plus 2. 9 plus 9 is 18, plus another 2, we have 20. So we can see that when you plug in the value that corresponds to the divisor, the y value that you get is the remainder. And that is the remainder theorem. So, f at a, when f at x is divided by x minus a, is the remainder. So if you have any function being divided by another linear function, the y value, when you plug in the a value, will give you the remainder. That's the key here. So the remainder theorem states that if you were to divide something, the remainder that you get is technically just the y value of that function if you were to plug in the corresponding x value. The second thing we want to look at is the factor theorem. This whole section, factoring polynomials, comes from these two theorems. Everything we're going to be doing relates back to the remainder theorem and the factor theorem. The factor theorem is one example of the remainder theorem. The factor theorem states that f at a, the factor theorem states that if f at a is equal to 0, so same thing that we talked about here, if you plug in a number and the y value is 0, so if f at a is equal to 0, then x minus a is a root of f at x. Remember, what does root mean? Root means the same thing as the x-intercept, which the x-intercept, it can also mean, it means it's a factor. And in this term, so if f at a is equal to 0, then x minus a is a root, it's an x-intercept, and more importantly, it's a factor of f at x. Let's look at how we would apply this. So as we've already done, as we've done before, we need to sketch a graph. The difference now is the equation that's given to us is in standard form. We know how to sketch if it's in factored form. So what we need to do is take this polynomial standard form equation and turn it into factored form. Fancy way of saying factor the equation. In order to factor it now, what's the first step? Well, I'll notice that there is an x that's common in all of them, and all the coefficients are multiples of 2. So I can factor out 2x. We're left with 2x3 to the power of 3 plus 3x squared minus 3x minus 2. So this is now our new equation. Now we need to factor this equation. To factor this, we're going to use factor theorem. We're going to find a number that if you plug it in here, this whole thing turns into 0. To find which numbers to start with looking, you're going to take the factors of this final term. So the factors of 2 are positive and negative 1, positive and negative 2. So we're going to try plugging in 1, negative 1, 2, negative 2, until we find a value that will turn it into a 0. So let's call this function here f at x. So we're going to find here f at positive 1, f at negative 1, f at 2, and f of negative 2. And all we're looking for is something to give us 0. So if we plugged in 1, this is 1 cubed is 1, 1 squared is 1, x is 1. So it would be 2 plus 3 is 5. Minus 3 minus 2 is 0. So f at 1 will give us 0. I don't need to check anything else. I'm looking for one term that will give me a 0, because that means this information here tells me that x minus 1 is a factor. So let's go ahead and divide in order to figure out what the factor would be. We will use synthetic division because our factor, our divisor, is linear. So it's x minus 1, so it goes 1 on the outside, 2, 3, negative 3, and negative 2. We're just putting the coefficients in descending order. 2 comes down here. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 3 plus 5 is 2. 2 times 1 is 2. Negative 2 plus 2, 0. That's how we know that it worked properly. And this is what we're left with. So now, this equation, 2x cubed plus 3x squared minus 3x minus 2, has simplified to be 2x is still here. This equation was divided by x minus 1. So x minus 1 is here. And then what's left over here is 2x squared. Because remember, this is cubed. So 1 less would be squared. Plus 5x plus 2. And then we would continue this factoring process to do the quadratic factoring of here, over here, and that would be so it'd be 2x plus 1, x plus 2, and this would be your fully factored version. And now let's finish off the question by sketching a graph. I'm going to erase this over here. Okay, so now back to graphing. X means that one of the x-intercepts is at 0. There's one at positive 1. There is one at negative 1 over 2 and one at negative 2. Now to draw a sketch of this function, we know that this is to the power of 4, even degree function, and it's opening upwards. And then every single one of these is a linear relationship at the root. So as long as I keep my lines going directly through, that would be a sketch of the function. The key thing to remember in factoring polynomials is that you need to find the factors first. Sometimes you will need to use the factor theorem process more than once. If your entire function, or the function that you're trying to factor, is greater than 3, then you might have to use the factor theorem twice, maybe 3 times, depending on how many times you have to do it. And it's important to review how to factor quadratics, because that will become important in almost every question that you do. Because once you get down to x squared, there's no purpose in using the factor theorem, and now it's better to use factoring that we've already learned before.